Hey everyone, we are back with another video. This is on section 3.5, Euler circles. Another way to refer to these is also Euler diagrams. And these are basically Venn diagrams that are used to prove or disprove the validity of a statement, like a conclusion. Okay, so let's work through some of these. You are familiar with Venn diagrams. So as we work through these problems, through these statements, trying to prove or disprove them based on the representations, you will understand how to use these Euler circles. Okay, so basically the idea is this. Let me just give you a quick background. So the idea is that when you are presented with an argument, it has uh, some premises. It could be two statements and then a conclusion. So the premises or the statements are facts. So we take those as facts. We assume the premises to be true. And based on the premises and on the premises alone, we're going to try to see if the conclusion is valid or invalid. If at any point something disproves the conclusion, if the conclusion doesn't hold in every single case, then we are going to determine that the conclusion is false. So we will go through these examples and you will build your understanding of how to work with these Euler circles as we go through the examples. So let's take a look at the first problem here. So as it is my custom, I'm going to go through the odd number problems and then I'll let you do the rest. So number one, it says match each Euler diagram to the correct statement. And we're looking at number one, it says some tigers do not have tails. So basically, you're looking at two sets here. We're looking at the sets tigers and animals with tails. As you can see from the Venn diagrams there, you have animals with tails and tigers. So think of these as two sets. And so we are looking for the representation that makes sense based on the statement. So if you look at number one, if you look at the first Euler diagram, A, this one is saying that all tigers have tails, right? Because all the tiger set is inside the set of animals with tails. So that wouldn't work. If you look at B, this one says that some tigers have tails, but what we want is some tigers don't have tails. So B wouldn't work. And then set the Euler circle C says that no tiger has tails, but we're saying that some do not have tails. So you can say, well, if not a single tiger has a tail, then some tigers do not have tails is true. Yeah, I mean, that is a good argument, but we're looking for the more precise representation. So keep an eye on C. I mean, I wouldn't say that it is not, because we're saying that some tigers do not have tails, and C says, no tigers have tails, which means that some tigers don't have tails, right? So, okay, but let's see if there's another one that is more precise. And if you look at D, this one, there's one tiger, namely X, that does not have tails. So then some tigers do not have tails. D is the more precise representation so far. And then E says that some animals with tails are not tigers. And then F says that all the animals with tails are tigers. So that's definitely not the right one. So we go with D as the more precise representation. Okay, so let me, I'm gonna leave the screen there with the Euler diagram so you can be looking at them as I am. So let's see, give me just 1 second. So if I'm gonna be writing here. You can't see my, oh, okay, hold on. Give me just a second. Okay, so number one therefore is D. Okay, so just write D for number one. Let's see number three. Some tigers have tails. So some tigers have tails. So you're looking for the tiger set and the animals with tails to have an overlap. And so for number 3, you can see that the one that has the overlap in the center is B, right? Some tigers have tails. So B is the answer for 3. And let's see, number 5, some animals with tails are not tigers. So basically what you want is an X on the animals with tails set outside of the tiger set. And if we look at E, that would be the one, right? So you have an X in the animals with tails and outside of the tiger set, which, is saying that some animals with tails are not tigers. So then 5 is E. All right. And let's go down to, you can try the rest. Make sure you try the rest for practice. Now 7, let's look at 7. 7 is some smart people do not go to college. So basically you have the 2 sets, smart people, and the set that people who go to college. If you look at the Euler diagrams, you have 2 sets, people who go to college and smart people, right? So here for number 7. And let's see, so some smart people do not go to college. So what you want is an X in the smart people outside of the people who go to college, right? Because you're saying we want some smart people don't go to college. So you want an X in the smart people set outside of the people who go to college set. And the only one really that has that is B, right? So I always like to go through all of them and just eliminate them. So with these, always try process of elimination. But as you can see here, B is the right one, right? Because all the other ones, A says that all smart people go to college. C says that no smart people go to college. D says that some smart people go to college. And then E says that some people who go to college are not smart. And F says that people who go to college, all of the people who go to college are smart. Okay, so the best one for some people, for some smart people do not go to college is B. Okay, so 7B. And last one, 9, last one of this type of problem. It says that no math courses are easy. So basically what you want is the math course set and the easy things set to be completely disjoint, meaning they have no elements in common. Because we are saying, the statement says no math courses are easy. So no math courses are easy, that means that the Euler, that the Venn diagram of math courses and the Venn diagram of easy things have to be disjoint. Disjoint means they have no elements in common. And the only one that has that is C. So 9 is C. And so let me stop sharing here to show you what I wrote. And so there it is. 1 is D, 3 is B, 5 is E, 7 is B, and 9 is C. All right. All right, so let me move forward here. So the next type of problem, I'm gonna go to the actual, these are the actual arguments written. So remember when I was explaining to you, usually we have 2 premises, sometimes 3, but 11, for example, has 2 premises. Some P is Q and no Q is R. So we're gonna draw the Venn diagrams based on the premises, and then we're gonna draw the different cases for the premises. Like, you're gonna see what I mean when I start drawing these. But remember, the premises are facts. We don't question the premises. And we do not add personal knowledge or common knowledge, even if it's common knowledge. We do not add anything except we just basically go by what the premise is saying. So we just know that some P is Q And then we also know that no Q is R. And we're trying to prove, we're trying to see if the conclusion based on those two premises is valid. So the conclusion says, therefore, those three dots represent the word therefore. So the conclusion here is, therefore, sum P is not R. So what I will do is I'm going to write the argument, and together we're going to create the Euler diagrams. And based on the Euler diagrams, we're going to consider every possible case. And then based on what we have, we're going to see if the conclusion is valid or not. Okay. Let me just write this down. So no Q is R. And then therefore, sum P is not R. Okay. So let me stop sharing here so you can see where I wrote. There's the argument. Okay, so remember, we know two things. We know that sum P is Q, and we know that no Q is R. So I can represent, let me create one case. So I'm going to call this case 1. I can have, I know that sum P is Q. So then I can have P and Q, the two sets. And then there's at least one P in the overlap of Q, right? Because we know sum P is Q. That's for the first premise. Now the second premise, no Q is R. Okay, well, we may have to do more than one case. No Q is R. So we have another set R that can, no Q is R. So what I know is there's another set R that may overlap P, but I know that it doesn't overlap Q, right? So no Q is R. So this is one possibility, right? That there's an overlap between P and R because they don't tell me anything about P and R. I just know that no Q is R, so Q and R cannot overlap. This is one possibility. Now, what's another possibility? I can create as many possibilities as you can think of that can happen, right? Based on the premises. Now we can also have, we know that P and Q have at least one element in common because we know sum P is Q. I can also have no Q is R, but R can be all inside of P, right? All of the R can be P. That's another case. And then another possibility could be that R never intersects P either. So notice that I'm just building possibilities and I have to consider all possible cases. So I know P and Q do have an overlap, right? But another possibility could be that I just know that Q and R don't overlap. So R can be over here, right? And then you have to look at the conclusion and see if this is true in all three cases. If you think of other cases, by all means consider them, but I think this is pretty much all cases. So let's see. Let's see if the conclusion holds in case 1. Sum P is not R. Okay. Well, that's true because we have an area here where sum P is outside of R. So that is true. Let me see here. Sum P is not R. So we have an area here outside of R and P, right? So sum P is not R. And then over here, all of this is outside of R. So yeah. So the conclusion is true in all three cases. So we say, okay, this is a valid argument. This argument is valid, right? This argument is valid. So that's number 1. Which is actually number 11 on the, but it's the first example that has the written argument like this, number 11. Let's go ahead and move to the next one. Let's see. Let's go ahead. So I did 11. Let me see. How about some elements are valid? Okay, let's go ahead and do 12. I know that I don't do the even numbers, but that one is a good one. So what do we have here? Let me see. I'll do 13 too if you want to, but let's do 12. Well, I wouldn't know it because you're not here to tell me. Okay, so 12, it says all x is y. So I'm gonna write it down. So all x is y. And then we have some x is z. And then therefore, some y is z. Okay, so that's 12. So we will just go ahead and do the cases here. So one case, it says all x is y. So you have x totally inside of y, right? That's one for the first premise. And then some x is z. Okay, well, we know that we can have some x is z. So obviously you have a set z that overlaps with x. So if it overlaps with x, it has to overlap with y, right? So it's gonna have, let's just say that, this is z. And some x is z, so I'll just put a red here in here. For the some x is z. There's an overlap between x and c, so that's one example, right? What's another way you can create this? So that's one case, right, that you can. So another, well, think about it. I mean, if some x is z, one other possibility would be to, I mean, there has to be an overlap with z and by overlapping x, when z overlaps with x, it has to overlap with y because x is totally inside of y. So I don't think you can build, the next possibility here would be, because z cannot be disjoint from x. So, and you can't put z totally inside of x because that would be all x are in z, right? Like you can't put x totally inside of z. So let's see. So some y is z. Yeah, some y has to be z. Notice there's the overlap. So some y right here, some y are in z. So there's an overlap between z and y. So this is valid, right? Do you see why? Maybe I should make it a little bit bigger so you can see. So what I had was we know all x is y, right? So all the x's are there. And then some x is z. So there's a z set, right? That overlaps because some x is z. So it overlaps with c. So you know that there's an element there, I'm going to put it in red, that overlaps between x and c. And when it overlaps with, because there's an overlap with x and c, it has to be overlapping y as well. So some y have to be in c by default, right? It has to happen. So another way you can is that the z, if the z is totally inside of y, I mean, another possibility, I guess you can say, this is case one, right? So you can build another case, but it wouldn't change the fact that the conclusion is valid. You can say, here's x, and then here's y, and then some x, you can have some x is z. You can have z totally inside of y here without leaving y, right? Because, some x, but then that would say, if you have this case, then you're saying all of x is in z. So then that's not what this is saying, right? So no, we wouldn't consider this one. So just this case, and it makes the conclusion valid, right? So the conclusion is valid for 12. And that is, you can see that, right? I mean, and with these examples, always, try to play with it because sometimes, we may think, oh, we have another case, but we really don't, because then we end up saying, oh, this cannot hold, which is good, we see it. So this one's valid. 12 is valid. Okay. Let's see. Let me see which one. Let me share my screen. Give me just a second. Go to the right place. Where's the workbook? Yeah. Okay, so I'm gonna do 15 here. Let me share my screen. All right, so there's 15. I'm gonna try 15. Let me see what else. I also want to do 12. 12 I already did. I'm gonna do 16 as well. 15 and 16. And then I'm gonna do 19 and 21. So I want to do a lot of these because I do think that the more you see it, the more you would be more comfortable with it. So 15, it says some birds can talk. Let me just write it. Some birds can talk. Some talking animals can also move, like the cows, right? Some talking animals can also move. All cows, also here we have three of them, three statements. All cows can move. And we have, therefore, the conclusion, some cows can talk. And I'm sure that you're already saying, I don't think that's a valid argument, right? But remember, we can't bring in common knowledge into the problem. We have to use the process here, just the premises and the Euler diagrams. Some cows can talk. All right, let me stop sharing here. And so we have some birds can talk. These are the premises. Some talking animals can also move, and all cows can move. The conclusion is that some cows can, there's a word can there, can talk. Okay, so we're gonna build the Euler diagrams here. So some birds can talk. So here we have the bird set and the animals that talk set, and we know that some of the birds can talk. So we put an X here because there is an overlap. And then we move on to the next premise. Some talking animals can also move. So this T, right? I have to, now I'm gonna have cases now. So case one possibility is, it says some talking animals can also move. So you can have those animals that move, they can have an overlap here, right? So I'm gonna use Y here for that, Y. So it's X and then here for Y. And then this is one possibility, right? And then you know that all cows, the next premise is all cows can move. So you want to put all the cow set inside the moo set, all of it like that, right? Now, okay, this is one case, right? Now let's see if I can build more cases. Another case can be based on the premises that we know, well, we start with the birds, right? We start, some birds can talk. We have the birds and they talk, some birds can talk like this. And then we can have some talking animals can also move. So you can have an overlap, some talking animals. You can have an overlap between the three, right? Because you can have, like, for example, you're saying some talking animals can also move. The move was outside of, in this case, it was not overlapping with the birds, but we can also have a situation where there's an overlap like this, and still, remember, you can't bring any personal knowledge. We just know that some talking animals can also move, so you can have that possibility where you have the move, where this is still true, that some talking animals can move, that where there's an overlap here, right, between the M and the T, even if it overlaps the B. This may be just, empty. All right. So, so remember, where is the X? The B and the T overlap. And then also the you have an overlap between all three. All right. Now the cows is way totally inside of C, right? So it's totally inside of M. I'm sorry, totally inside of M. So cows, but it doesn't tell me. I just know that it doesn't tell me that cows overlap B or T. None of the premises tell me that the cows overlap with the other sets. I just know that cows is inside of M, but it doesn't tell me that it overlaps T or B, right? So we cannot conclude that some cows can talk. We cannot conclude that C is going to overlap with T based on what we know, right? So this is an invalid argument. I'm not really convinced that we can create this case here because all we know is that some birds can talk. So I know that there's an overlap between B and T, and some talking animals can also move. So there's an overlap between M and T, but nowhere does it say that there's an overlap that we can say, birds. Well, I know birds talk. Well, here we go. Some birds can talk, but nowhere in the argument in the premises is telling me that there's some birds that move. So I don't think we can actually, by looking at this, I do not think that we can present case two actually, based on this, right? So I don't think we can even present this case. So I'm gonna delete it because nowhere in the premises is allowing me to say that the birds have an overlap with M, right? I just know that some talking animals, but I'm not sure about the birds, that they also move, right? So I can't. So this is basically the only case. And based on this, some cows can talk. I don't think that we can make that argument because C is totally here outside of the talking set, right? And so please play with these, like, even if you think you can come up with a case, try to disprove the case yourselves, see, okay, does this make sense? Do I have enough evidence here to support this case? And by looking at it, I went again and constructed the case, but then by analyzing the premises, I conclude that I can't build this case, but this I can build. And based on this case, I say that the conclusion is not valid. And so this argument is not valid. So we're going to say invalid, right? Okay, so that is number 15. And we're going to do also, how about we try 16? You want to try 16 also? I wish you could speak back to me here. Okay, let's try 16. 16 says that no cats are dogs, all tigers are cats, all Bengals are tigers, and no Bengals are dogs. All right, so let me write all three statements here. So 16, no cats are dogs, all tigers are cats, all Bengals are tigers. And then the conclusion is therefore, no Bengals are dogs. Okay. So let us begin drawing the Venn diagrams. Okay, no cats or dogs. So we have two disjoint sets, dogs. Cats and dogs are disjoint, right? And then the second premise, so we got this one. All tigers are cats. Okay, so all tigers are cats. So you have, I'm gonna draw this bigger. So this is C and this is T. All tigers are cats. So you have tigers inside of cats. So there's a T. Okay. And then, so we got this one. All Bengals are tigers. Okay, so then we have another set B inside of T. I need to draw this bigger. So, okay, here's C. And then we have the T set, and then we have the Bengals inside of T, right? So because we're saying all Bengals are tigers. So this is basically all we have. This is the only case you can build right here. Okay, so once again, no cats or dogs. You begin by saying, you know, you have a dogs and cats, this joint, right? And then we're saying all tigers are cats, so T is inside of C. And then all Bengals are tigers, T, you know, here's T, so B is inside of T. And the conclusion is that no Bengal are dogs. And that's true because look, B and D are totally disjoint, right? They're totally disjoint. So that is valid. That is a valid statement. Okay. So this is valid. Okay, so once again, no cats are dogs. All tigers are cats. All Bengals are tigers. Based on those three premises, the conclusion is no Bengals are dogs. That is so true. This is valid. You can see how. So you begin by writing C and D, disjoint. They don't have anything in common, cats and dogs. And then tigers, all tigers are cats, so all the T is inside of C. And all Bengals are tigers, all B is inside of T. Therefore, B and D have no elements in common. So then we can say that no Bengals are dogs. That is true. That's a valid argument. Okay, so that is a valid argument. This one is straightforward. I like this for a test question. Okay, and if you were here, you would probably agree. But you can always email me and let me know. Remember, email me with feedback regarding the videos. I will be waiting for those emails. Let me know what you think, because I want to improve if the videos are a little bit long or if they should be, and anything that you want to contribute to, just give me feedback. I truly appreciate it. Okay, so that's number 16. Let's see, let's go ahead and do 19. Because, oh, this is a different type of problem. Yeah, let's move on to a different type of problem. It's almost the same, but now we have to write the conclusion. So based on what we read, we have to see if we can write a conclusion. It says write a conclusion so that the argument is valid and use Euler circles. If it is not possible to write a conclusion that makes the argument valid, state so. Okay, so we have to see if we can write a conclusion that makes the argument valid based on the premises. And if we can't, we have to say, well, we can, right? We can. So let's take a look at 19. And what do we have? All whales are mammals. So I will write 19. All whales are mammals. A parrot is not a mammal. And then we're gonna see if we can come up with a conclusion. So first, let's draw the Euler diagram. It says okay. So all whales are mammals. So I have all the whales inside the mammal set, right? And then a parrot is not a mammal, so you have parrots over here, all the parrots. So therefore, the parrot is not a mammal, right? We can say a parrot is not a whale also, right? Oh, I'm sorry. A parrot is not a mammal, that's the premise. I can't use that. But you can say a parrot is not a whale, right? So you can say, therefore, a parrot is not a whale, right? That's one conclusion that will make the argument valid. So that will make the argument valid for 19. An easy conclusion, you know. Okay, so that is 19. And let's see, let's do one more. We'll do one more so that the video is not too long. Let's do 21. Oh, that's the last one. So we'll do 21. And let me write it. No birds are dumb. No birds are cats. And then we're going to come up with a conclusion. Okay, so no birds are dumb. So the birds and the dumb set, we're going to put them separately. And then that's the first premise. No birds are cats. Okay, well, you can have cats overlap with D, right? One case. Or you can have all of them disjoint, right? So case 1 and case 2, right? I just can't have B and C overlap, right? Because of the second premise. And the first premise, I can't have B and D overlap. So you can have a conclusion here. Well, unfortunately, I can't come up with it because this contradicts, you see, this case contradicts because here we're saying that some C or D, but over here I'm saying that no C or D. So I can't write, they contradict each other, the cases. So it is not possible to write a conclusion that will make, that can make this argument valid. Okay, so therefore this is not possible. Okay, so that's 21. I think you have a good number of problems to help you with this section. This is a really fun section. Remember, sometimes you have to, you come up with a case, but look at the case carefully and see if it's valid, if it makes sense. So, because sometimes, like it happened when I was doing considering the cases where, I thought this was a case, right? And I said, oh, you know what, this doesn't really work. So you need to try it. We learn on our feet, but pretty much with these problems. All right, so, all right, guys, I think that's it for this section. Once again, don't be a stranger. Email me. You can also call me. I'm gonna be giving my, you can email me. Don't call me on the office because, I rarely check those messages there. Just email me and then we can, if you want to meet via Zoom for tutoring, we can definitely schedule a session. All right, so, okay, I think that's it. I'm out and I will see you on the next video. And you guys stay safe and God bless you. Bye-bye. Take care.